Hello, my name is Ken Adams. I'm a research professor of quaternary geology and geomorphology at the Desert Research Institute in Reno, Nevada. And this is one of a continuing series of videos about quaternary geology of the Great Basin. So, the last little video, you might not be seeing these in sequence, but I was talking about the surface characteristics of the youngest alluvial fan here on the Wasatch Range front. And Walker Lake is off to my left, and the Wasatch Range is off to my right. This is in western Nevada. It's a very active range front. There's a lot of different age alluvial fans. There's different age shorelines. And based on the ages of the shorelines, we can work out the stratigraphy of the fans as well, and then also have a sense of how old the fault scarps are on this range front based on what age units that they interact with. And so the youngest alluvial fan unit is downslope. That's that thing with the big old boulder on it, with another big old boulder sitting on top of it. And that fan surface down there is younger than 1,500 years because it buries a 1,500-year-old shoreline. And so we're up above the range front fault scarp here, the main range front fault scarp, on an older fan unit that's been abandoned because of this faulting. And so one of the main differences that you see right away between this relatively older fan surface up here and the youngest one down there is that these boulders are more weathered. They're a little bit darker. And you don't see, there's only very few of sort of the bright light-colored granitics. These ones are all kind of turning brownish, tan. Let's walk around here a little bit. The surface up here is smoother. It's still very coarse. There's lots of big boulders, but the intervening areas between the boulders, another lizard is running for its life. The surface between the boulders is smoother. There's less bar and swale topography, fewer levees. I don't think that this fan is very much older. It's not Pleistocene because this fan formed after the Lake Lahontan, after Lake Lahontan receded from its high stand at about 15,000 years ago. And so the Lake Lahontan high stand was way up there. It's pretty high above us. And so there's another surface unit here that is this steep slope out in front of us. And I don't know if this video has enough resolution to show the difference between weathering. So you got these sort of not really light colored but big boulders. And there's another one. And then you go over onto this surface and all this stuff over here, still big boulders, same size. This is a wave modified slope. On LiDAR data you can see that there are subtle shorelines cut into that surface. And it probably started out as alluvium, but it's been wave reworked, at least the surface of it. And that was probably last touched by waves, last touched by anything that would move those boulders on the recession from the Lahontan high stand about 15,000 years ago, 15.5, which happened really quick. The Holocene shorelines don't get up this high. And so those boulders tend to be a lot more weathered. They're not very punky or anything, but they're a lot browner than and darker than these ones on this alluvial fan. And much browner than the ones on the youngest alluvial fan. And so there is a relative age sequence here in terms of how long the boulders in these various deposits have been sitting out here, baking in the sun, being frozen in the winter, all of that. And so you can start to work out the relative stratigraphy, and it should agree with any sort of numerical ages that you estimate via cosmogenic weathering, cosmogenic surface exposure dating, or if you were able to find radiocarbon sample in these deposits, or if there was one of the young monocraters tephras. All of your different lines of evidence should agree, and it's kind of nice when they do, and it's kind of frustrating when they don't. But if you were here collecting, trying to collect surface exposure samples for cosmodating, you would probably want to go with kind of the average looking weathered boulder on this surface, not the one that's most weathered, not the one that looks the freshest, because there's a pattern here. Up there, all the boulders are kind of brownish. Here, they're lighter colored, and down in the younger one, they're very light colored. And so that would be one approach that you would try to employ that would ensure that you're getting an accurate date of the particular surface you're dating.